Again, thanks and welcome everyone. Thanks so much, Mike, for that introduction. Yeah, you like painstakingly walked us through like many try-catches. I wanted to evade. I really tried hard to like not have more try-catches in my life. Okay, yeah, this is like my little snitch app. Apparently, Apple Maps wants internet here. Yeah, I was like, so to give a quick recap, many of you might know me as the founder of Prisma. In 2020, I wanted to get back into being a software developer again, just like getting my own hands dirty, building things, and while trying to figure out like what I would be building, I knew there has to be a better way to build things, since like the way how I've built things before with TypeScript didn't seem like a very fun path to me. So I've been like looking around for better ideas, looking around in like different language ecosystems, found some of those in like partially the functional programming community, partially in Rust, etc. But then I also realized, okay, do I want to go all in on Rust? Do I want to do like memory management all day? So the answer to that was mostly no, but I tried to find like, hey, can I bring some of those great ideas that I found in those other languages to TypeScript? And this is how I somehow found out about Effect, which was very early at that time. I was like, as I'm used to as a TypeScript developer, when I find a library, the first thing I do is like look for the examples folder. Was no examples folder, reach out to the author, ask Mike, hey, I'm Johannes, like TypeScript dude, are there any examples? And Mike felt pretty offended and told me to read the source code. Somehow I still stuck around. By now we do have more examples, but I somehow figured out my path, and for the past 2.5 years now, I've been working on various projects. Today I'm going to talk about one particular project and kind of like the patterns that have emerged while working on this project. So originally I wanted to call this talk Effect in Production, since the app has not technically launched yet into production, and since a few people have accused me of like over-engineering, I felt it feels more honest to call this talk over-engineering overtone. And so yeah, this is a high-performance music app that I'm trying to build. That's kind of my main thing that I'm currently working on. I'm also helping out at Effect with like all things developer experience, or whatever you'd call that. I'm like passionate about open source, been also involved in doing some R&D over the past few years, and also do some consulting to stay afloat. I live in Berlin, like music a lot, great place to be for music in Berlin. In this talk, I give you first a little demo of the thing that I'm working on, just to prove that it exists and works. Then I want to share what were the reasons, what was so compelling to me about Effect, and kind of like the promise of Effect, no pun intended. I want to give you a little architecture overview of like oversimplified, but still like give you an idea of the architecture of what I'm building, and then we can just like semi-randomly walk through a couple of deep dives of what I think is like our interesting patterns of the app. The latter part is mostly going to be like more of like architectural nature, where I'm going to show you like relatively little code, but more of like the patterns that I've been landing on that were just like super nice to work on with Effect. My main thing that I'm working on is called Overtone. I've been growing increasingly frustrated with how I can listen to music. I'm very much into electronic music, where I listen to stuff on YouTube, on SoundCloud, on Bandcamp, on Spotify, etc. And if you compare that to how email works, I can have like my email address wherever I want, Gmail or like a work email address, and I can then use whatever email client I want, for example, Superhuman. With music, we have to put up with like whatever more or less crappy app the music platform gives to us. I want to have like a really high quality third-party client for my music where I can have give a home to my music. I'm building this in this sort of fairly new architectural approach called local first. I won't go too deep into that today, but if that's your cup of tea, talk to me or like follow me on Twitter, X, sorry. And yeah, so a few features that I think stand out here or that are really top of mind for me is that it should be fast. I want to have syncing between the different apps or the different instances. It should be privacy preserving. For example, Overtone is really literally just an app. There are no servers, like similar like Winamp. Fun fact, Winamp still has 42 million active users. And yeah, surprising. But I think this was like one of the peaks of software quality. I'm kind of nostalgic about that and aspiring to reach like similar heights at some point. I keep pushing back the time when it's going to be live. My current estimate is like mid 2024. When that time comes around, call me out on it. But yeah, how I'm building Overtone, most of my past experience has been really around building web apps, kind of like starting with PHP and so on. And I've realized that while you can be pretty productive building web apps, they don't naturally always lead you to like the best possible user experience. And the apps that I enjoy using the most is like, we ask like, oh, is it native? Whatever that means. But from like more native level development practices, I try to be as inspired by that as possible, and also from like how game development works. Since we all want games to be like as performant as possible, whereas like our web apps keep getting slower and have like more loading spinners. Speaking of the loading spinners, the answer there that I think gives you pulls you in the right direction is to build things in a local first way. Out of scope for today, but that's super important and compelling to me. I focus a lot on performance, probably maybe too much, but it's also turned into a bit of an obsession and trying to see how far I can push the web. Yeah, I mentioned I haven't shipped yet. That's because I keep investing into a better foundation. I am inspired by like a company like Figma, for example, who also has not launched on day one, but they've also invested quite a significant amount of time first into a solid foundation, which gives them like the technical innovation that they had at this time. And that's an approach that seems very inspiring and compelling to me. So those are kind of like the directions. Since we have a few VCs in the office here as well, who are asking whether I'm raising, I'm turning this into a lifestyle business. Just to get this out of the way. A little demo. Technically I am connected to the internet here, but the app would not need internet. I should hit this Command plus a bunch of times. And let me also disable this for a second. So this is the app. It seems to play back right now something. So this should be the foundation should be pretty obvious. Like you can see like your music collection here. You can like traverse between your different playlists. You can do advanced things that Spotify doesn't let you do, such as like sorting your music. Or like searching through your music. So if you want to like search something here, like table stakes that somehow got degraded through the enchilification of software. I want to share more of like how I built all of this. And yeah, so that's kind of like a super small demo. What's maybe cool about this is you might have seen it here before. The screen I think is like a 60 hertz display, but typically if you're like been looking at this like at a 120 hertz display, I'm trying to keep the app basically responsive to 120 FPS right now. Hence the title, over engineering overtone, but yeah. So jumping back here, switching to why effect. I mentioned it initially that I was looking for like better ways to build things with TypeScript. And since otherwise I don't think I would have embarked on this journey to build something like overtone. I think it would have like straight up not been possible for me to deal with all of this complexity. And so the benefits that effect give me really empower me to do that. So I think as like developers or engineers, we're always like thinking for like, we're always going after like the perfect abstraction as like composable, etc. I think very few technologies actually give you those benefits. I think React has been a pretty enlightening step forward in terms of composability around view programming, etc. I would argue that we didn't really get a comparable thing to React that makes software more composable outside of view programming. Like your average function or async function, unless you're super duper diligent, like turn everything into a function parameter, etc., this is not really composable. And so most of the packages that we have on NPM, they all like feel very incoherent. They don't work together. They're just like also built in different eras of the web, and are therefore like also requires so much work to put all of this together that I don't think they're truly composable yet. And the other side of the coin of composability is if things are composable, then they're also reusable, and that's a really big deal, since I want to reuse something that others are building and provide things that I'm building to others. It also makes your code more testable. We've seen the observability aspects of effect. That was really also a pretty big step forward for me in terms of how much I'm enjoying working on something, since if shit goes wrong, I don't want to like add console log to different 20 places in my app. Maybe I've commented it out before and I re-commented in to kind of figure out like, okay, where is the problem? Maybe I go into a debugger, or like observability just like adds another superpower to our tool chain here. So there's no going back. Type safety is kind of thing I care about. It's also one of the reasons why I've built Prisma. And so we couldn't be more type safe with effect for various parts of our program. So the way how I think about it is that normal TypeScript, when you look at promises, etc., that gives you type safety for the happy path. But after that, you're kind of left alone. Like how a program can fail, like no idea on the type signature level. So that's where effect helps and way beyond. And this is something like this. The next point is kind of like a very emotional aspect for me, which is when I'm working on something, like I maybe just got it to a point where it just works, and then whatever, then we ship it on a Friday afternoon. But the next time when we actually need to make a change to it, even worse, if you need to make a change to some code that you've written a year ago, or your previous coworker who's no longer at the company has written, like touching some code, that making a bigger change, and like doing that with confidence, I think is like pretty rare in most complex code bases. So I wanted to have a thing, like a system where I can confidently make code changes like wherever in the code base without the entire like house of cards collapsing. And that's like for me probably the most important thing about all of this. which is like, yeah, makes it super fun and keeps it fun for me to work on a project. Typically, the longer a project exists, the more tech debt you rack up, and the more scared you get to change something. So that's a big deal for me. And yeah, batteries included. This is I think a commonly used buzzword, but for Effect has such an extensive set of modules that are just ready to be used in various use cases. So that's kind of like my answer to why I've chosen Effect. So let's dive in. The following is like a couple of a little portfolio of patterns that I've noticed about how I've been building Overtone that I thought was interesting to share. I'll happily invite all of you to ask questions about this. Like if you're thinking, okay, what the heck, why, what is this about? Please ask questions. And I want to share a little anecdote that's really around the confident refactoring. This was like fairly early in my Effect journey, where I built the first version of Overtone in a not yet local first way. So back then I've like tried to keep like all of like the state already in SQLite and in the front end. I see some like temporal affiliated people taking pictures. So the first version was not yet local first, where I did like most of like the more heavy lifting of interfacing with Spotify, etc. I did that in a temporal workflow because I thought, okay, this is going to be like very tricky. Like this will run for a long time. There's things that can go wrong. So I really need like some help to like run those workflows. So I've at some point started to refactor those. For those of you who are familiar with temporal, their workflows and their activities. The activities are typically like a promise that you run or maybe rerun. So I've started to refactor my temporal activities to be effects instead of promises. And so in those effects, I started modeling in like all the things that it depends on. So those, for example, depended on a file system, they depended on a database, they depended on a Spotify client. And as the app progressed, I like fell in love with the idea of local first, and I thought, do I really need this temporal thing? Do I really need to run this code in Node? Could I just run all of that in the browser? So that was kind of like a daring idea. I didn't think it's I thought it's gonna require a lot of work, but still, like I went ahead and I basically kept the activity code as such as it was before. I've just now changed the provider around it, like think about it like the React context. Effect has a similar thing for the Effect context. So instead of there providing a SQL client that works in Node, I provided a SQL client that works in the browser. And instead of having a file system from Node, I provided a file system works in the browser. I didn't change the activity code at all. And then after a bunch of preparation, the day has come where I've like first time tried to run this in the browser and it just worked. And that was like for me unheard of, like moving some pretty complex code that I've before only ran in Node, like moving that into the browser, into a web worker, and it just worked. Like that blew my mind and gave me like a lot of confidence. And that's like, I had anecdotes like this all the time. And I don't think if you've ever like had a very complex program that you've written for Node, like a CLI, then you run it in a browser, like shit goes wrong left and right. And so, yeah, this was a pretty encouraging moment for me. So this is a oversimplified architecture diagram of how Overtone overall works. So on the left here, we have a big box. That's the browser. Over there, we have another box. Those are like the external music platforms that I'm integrating with. You might notice, where's the backend? There is no backend. So the entire thing, Overtone, what you've seen before, just the Overtone app, no API server whatsoever that I need to run. Like in the same way as like Winamp. Winamp just works. No Winamp cloud that you need to like authenticate first. And that makes it also, speaking of like having fun building something, like not having to run servers, so refreshing. Big browser box, two slightly smaller boxes. There's like the main thread, which I think like most front-end apps are like just thinking about this and aren't really aware of like main thread, not main thread. But we have the main thread. I try to keep the main thread as simple as possible to the bare minimum there. So most importantly, I have like the view layer and the data layer in there. For the view layer, for the rendering, I'm using React right now. And to keep the app really fast, so you might notice this. All of this here, like all of the big table here, my initial version of that was just like to use like React table or something. And that was just, my computer was getting hot and it was like definitely one of the biggest performance bottlenecks I had in the app, even if I layered on virtualized rendering, etc. So I was kind of questioning, should I stick with the web or not? Should I like maybe still go back to all the way Rust? And then I found a great component called Glide Data Grid. We actually have David here from Glide. And so they've been generous enough to open source a major component of the app they're building, which is this Glide Data Grid component, which performs super well and is now like a super important foundation of Overtone. So if you ever need to like build a high performance table thing in React, highly recommend checking this out. That's the view layer. The data layer, this is where, I mean, I've tried like all the different things from the past, whether it's being like your Flux flavor, like with Redux, etc., or whether it's MobX, Zustand, Jotai, any of that. They like all work, but I think they're all optimized for like simpler use cases. And I needed a more solid foundation for state management. And there is a thing that's a pretty solid foundation for state management. It's called a database. So I wanted to bring a database into my app instead of just having a database on the server and then doing like all the crap with like API, serialization, Like what if we can have the database in the app itself? Also mostly outside of the scope of this talk, but it's another really important pillar of the app. So this is where we are running SQLite in the main thread of the app. We have live store on top, and in some parts of the app, I'm also using GraphQL for like convenience purposes. So that's the data layer. Now we're getting to the parts where I'm using effect. I have here effect services. Services might sound a little bit like microservices, whatever. Like it's basically, these are discrete units that do a certain thing. So I have a playback service, which is responsible for playback. I have an auth service, which you get it. Like you can read the things, images, caching, import, like data importing. I have different services. They mostly delegate to over here, where I have a pool of web workers. That's kind of doing the heavy lifting. For example, downloading images, resizing images, caching things. I'm using a fairly new browser standard called OPFS, which is basically like a file system, but in the browser. Think about it as like a replacement for IndexedDB. So I'm trying to do as much of the heavy lifting in web workers. Each of those tasks are implemented as effects, and I can schedule them from the main thread, run them, and get back the result. Mike has so far only showed effects, but there's kind of like a sibling of an effect, that like an effect only returns one value, whereas there's also an effect stream which can return multiple values. So I can also from those tasks stream in their results. So when I'm like going to a new artist, I haven't like fetched all of their stuff. I can like stream in the results, and it feels just like I'm using an effect. So I won't go into all of the services. They're like just business logic and not that spectacular. What I think is worth mentioning is the task scheduler. So this was kind of like a thing that I was really hoping I wouldn't have to build. But to make the app really fast, I ultimately had to. So what this is about is, given all of this code runs in this main thread, and kind of like, in a way, most importantly, React also runs in the main thread. React is the thing that like gets some state, spits out HTML that needs to render. This needs to happen ideally every time your display refreshes. If it takes too long, then like your app janks. Gets worse if you have a less capable computer. And so I needed to really protect the render loop. This is where it kind of goes a little bit into like game development methodologies. And sometimes I had just too much work that I need to do, and would just like exceed the render loop and sometimes even like block the UI for 5 seconds, which is unacceptable. I mean, if it's temporarily 30 FPS, no one cares. But if it blocks your UI for like 5 seconds, that's like unacceptable. And a big reason for that is because I don't have a backend. This needs to do all the things that your app needs to do. So I need to be very careful of like how much work I'm doing at a certain point in time. The great news was, since I'm doing like expressing all the work that needs to happen through effects, turns out the way how effect runs stuff is going through like a level of indirection, which you mostly don't need to think about, but it's very similar to how React is actually executed in the React fiber system. Effect also has a fiber system. And that fiber system, I can interject a scheduler. And on the main thread, I can basically say, hey, here's a scheduler that is aware of the render loop. And so it tries to do as much work as possible within a frame. Then it realizes, uh-oh, like I'm like out of budget. Then it yields back to the browser renders, and then continues doing the work. So this way I can, the priority is to not drop frames. The second priority is rendering, maximizing the throughput of the work. And so this is something that I think would be like straight out, like close to impossible to do without something like effect. I think the way how React suspense works, or like the React fiber system, they also have like a time slicing mechanism. So I kind of had to build a similar thing, which was made much easier with effect. So this is, if you want to build like really high performance front-end apps, you got to think about that. If not, good on you. Yeah, and so I think this kind of gives you an architecture overview. Any questions about this so far? Yes?
Did you try doing any of these things without effect, and what were like the performance differences that you saw?
Right. So we got a question whether I did any of those, whether I tried any of those things without effect, and whether I saw like a performance difference between doing it without effect and with effect. So I can't tell you that I've like constantly also simulated a parallel universe where I've like implemented everything step by step as Mike did without effect. I've ran like some experiments of like things that I thought could be bottlenecks with effect and without effect, or to prototype something. What I've always seen is like that effect maybe adds a teeny tiny bit of overhead on the execution, but maybe like in the, not even like a % or something, but the simplicity it afforded me to do everything with was just like for me out of the question. So if you want to build, I don't know, like a highly optimized academic algorithm, like a sorting algorithm, don't use effect. If you want to do something like business logic-y, I think effect is worth it if you can get over that hurdle of like, I mean, the code we've seen before, is a little bit weird. Like it takes a little bit of getting used to. It reminds me of like when I saw React the first time, and I didn't like hadn't like rewired my brain yet to like think about things as components, etc. So it's a bit similar here, but in my opinion, like the highest praise I can give to this is like overtone would not exist as it does without effect. So it gives me like, yeah, I think it's basically scales my abilities by a lot. Yeah, I hope this is like a somewhat satisfying answer. All right. Yeah, over here.
So I just want to make sure I got the architecture right. So is the view basically another service in your app, similar to the other effect services?
All right, I'll repeat the question one more time. So is the view just yet another service in the effect services? At the end of the day, it kind of doesn't matter as much. I've started out that like when the app boots, that React kind of kicked everything off, and then like it's like the first component in my React app, I can like the use effect and like started everything. At some point, I flipped everything where the initial code that's running is effect, and then the view layer becomes an effect service. Where it helps me with that, overall, I don't think it makes a huge difference. Where it helps me is like when I reload the app and you like see this loading spinner. So you see the loading bar. This is actually like it's relatively quick. I want to make it quicker, but this is where like you have the like it boots up the database, boots up the auth, etc. And so effect has a concept that we'd left out in the initial presentation just to not overwhelm too much. But effect has a concept called a context. So think about it similar to the React context. You wrap your React components with that context. And in that context, you could also do some async things to say like, hey, now I'm done. Effect has a kind of similar concept, just that it's much more composable and you can do multiple things concurrently. So while this is running, it's doing like a whole bunch of things concurrently. And then at some point when it's sufficiently ready, then it loads the corresponding React component. So, but yeah, that's kind of up to you, and there's like no right or wrong here.
Presentation. Actually, really like I can study this for a long time and still figure it out. So, two questions. One very easy, which is, do you have a data sync layer to a server, or is this only client?
Yeah. So I mentioned before that like I want to share like some emergent things here. Like as I'm working through this, I like built something at first crappy version, then I realized, okay, I gotten it wrong, but that maybe gives me an idea of like doing something different. The way I don't run any servers. The servers that I interact with are like the music platforms. And so the way how I'm interfacing with those, like the very first version was where I've like just had those temporal things, and like I basically like to prepare even me like toying around with the app, I prepared like a big SQLite database that said like it has the data for my library. Then I used that as a snapshot, loaded it in, but that's obviously not the user experience that I want to provide to people. So users should like sign up with their Spotify, and then step by step their like data should come in. So the pattern that I've now landed on is, so I have actually a slide on this. And I might also open source a part of this. I call it diffstream. So the problem statement here is that most of those services just provide like your average like CRUD API, where you can say, hey, for the playlist with ID 42, give me all the stuff for the playlist. You get a big JSON dump. And then, but the question is like, when do you call that? Do you call that when you open the view and you don't show anything before? Or what is happening when you open it the next time? do again like fetch everything. So ideally, those API endpoints would also provide a way to get only like a change set of what has happened since the last time you've opened it. So I've built myself a little thing that I have in the web worker that basically keeps track of the previous snapshots, and then to the main thread only tells the main thread like, hey, this little piece of data has changed. So like this is just like a little playground where I've like evolved that thing. So over here you have the old snapshot. I've highlighted like some of the data that's now different in the new snapshot, and you basically get here like an event log of, in this case, 2 events. Hey, this track has updated. Here are the new fields, and hey, here this track artist has for this track one of the artists has been removed. So I think this is kind of like a ETL-y thing just for applications. I've like looked whether there's like any enterprise pattern for this. I've even asked Martin Kleppmann about this. Seems like this is a novel thing for applications, but yeah, happy to like I invite everyone to like poke holes into this since it's very useful for me, but I don't know yet where this will fall apart. So this is like a answer to the way how I understood your question. Over here.
It's somewhat interesting with effects and like kind of fibers.
And then what you're doing here with like kind of the diff stream is very reminiscent of Meteor back in the day.
Yeah, I have a lot of respect for the folks who built Meteor back then. I think it was very much ahead of its time, and it had to solve too many problems at the same time. So who knows if it came to be a bit later, maybe everyone would be using Meteor still today. I think there were many great ideas. Many worked, some didn't, but I think there's probably like, I'm sure that people thought about this before.
We're all just doing them 10 years later.
Yeah.
But
So,
in separate packages that we can adopt in sustainable ways.
based on effect.
Yeah, very cool.
Sorry, got one more question. So I'm building something with a similar architecture, and one thing I've had a lot of trouble with is doing migrations. So when you have a database on the front end, and then you push out a new version of the code, and then you need to do a migration, is that something you've had trouble with, or not really?
So I've mentioned built Prisma in the past. Part of Prisma is also trying to do database migrations. That left some scars. I wanted to find different paths, and the way how I'm trying to avoid this problem entirely is by following a different data architecture where I'm doing event sourcing. So I just keep an event log. If I change my database schema, I'll just blow away the entire database and start rehydrating all the events, and it's great. I love it. But yeah, might be not the answer you've been hoping for.
Yeah, cool. So just to follow up on the diff stream thing, have you looked at SVIX, SVIX, no relation?
Hold on. Mike, you need to hold the microphone now.
They turn like JSON objects into webhooks.
Swix.
SVIX. Yeah, no relation.
Oh.
Anyway, I'll just suggest that.
Can you send me a link or something?
Yeah, I'll send you a link.
Okay.
The actual follow-up is I think there's a lot of potential in this architecture that you set up. I think a lot of apps should probably follow it. If effects is, sort of like the React aha moment for it, you might be doing the next JS for it. Like,
Maybe.
This is the framework.
So the way how I've been thinking about it, or like when I showed this to other friends and they had like similar reactions, I think there's like an analogy to how like Unreal is like a game engine, and this could be like an app engine if Google wouldn't have ruined the term already. I don't. So the closest thing that I'm ready to share with a wider audience is this thing, this live store. This was previously a research project from two MIT PhD students worked on it, Jeffrey Litt and Nicholas. I actually also have a slide on this. So I've collaborated with Jeffrey and Nicholas on this for 2 years. And so the research project is called Riffle, which is basically about this idea like, hey, can we do better than MobX by bringing SQLite into the main thread and add a reactivity system on top of it. So I'm right now in the process of productionizing this. And so this is what live store is. And so at least there's like soon 2 of those, of this like stack out there with effect. And well, effect and live store, you can use GraphQL already, React, Glide Data Grid, all of that is there already. The other things I would say are rather like now the patterns that I want to share with people. I'm not sure, I want to kind of like go bottom up with something that I think is reusable as itself and not yet go full Meteor and say like, hey, here's like the getting started thing for like your linear clone. But who knows? Okay, thanks so much for those questions. I have a few more slides. Yeah. Okay, there's another question.
Quick last question. So you mentioned that one of the reasons you use it is you could prioritize the main thread work and then kind of decide when it would be consumed by the other stuff. But how do you handle like different clients, particularly mobile ones, where they have different constraints? Like, is that something that came up while you were kind of playing with this?
Remember when you've been buying games and you like turned around the game envelope and it said like you need at least this kind of computer for it, and otherwise the app would lag, the game would lag. I think there's a similar situation here. Not that the specific to this is like already the case for like most React apps, etc. So whenever like you just willy-nilly install something from NPM, that someone who's not performance-minded, like whatever, puts together, who's like not aware of like big O complexity and so on, it gets worse and worse. So you just have to be very diligent about this. So I'm just super careful about vetting all the I have like very few dependencies. And the dependencies that I do use, I study very carefully that they don't mess stuff up, to somehow like that, to not let this out of control. I don't think this is like a very reasonable advice for everyone, just like be as diligent as me, but that's at least what I'm doing right now. And I think, I mean, yesterday, whatever, this week we got like new M3s. So things are getting faster. Overall, hopefully, if you wear optimistic lens, software is getting better. I don't know about that. I'm trying to help a bit there. But so over time, that problem should get less relevant. And the great news is if you use something like React, that already helps you with React suspense and that time slicing there. Still relatively easy to shoot yourself in the foot. So you just need to like keep performance somewhat in mind. Sorry for that non-answer.
Awesome, thank you.
I have a few more slides that we can go through, but I'm also not sure how we're doing in time. Do you all want to see like a few more slides? Yeah. Okay. So this is probably the only code slide that I have. And this is, sorry, I can't do Command plus here because it's a screenshot. The point of it is, this is called main live. Live is sort of like a convention we have in the effect ecosystem when you compose all things together, and that's the thing that you want to use in production as opposed to testing. Then like this is how you, almost like your app component in React where like you like put everything together. And here I'm basically just combining all of my different services. And what's really nice about this is like this is basically kind of like a self-assembling dependency graph of my app that like knows the dependencies between each other. So for example, the Spotify API client requires a cache the cache requires like OPFS. So by me just saying like, hey, here's all the stuff, figure it out, that's great, like, because that's tries to boot up the app as quickly as possible, manages the dependencies between each other, and I can see on a type level what a certain thing requires. So if I have like a function that requires a Spotify API, I see it on the type level that that thing requires a Spotify API. And when I try to start my app without putting all of this together, the type system will tell me, hey, you're still missing, you're still not providing the Spotify client here, and it doesn't compile. So it's basically, yeah, this is like React context, but supercharged. So this is, in a way, the sum of like the summary of like my entire app, which will, maybe this looks foreign, but if you're using Effect a bit, this will be like very second nature. Here's like just to give you a little bit of an idea for like a pattern that I think is like very hard to do well without Effect, and with Effect where you have like great building blocks, it gets super nice to do. So the situation here is like the Spotify API, which, fun fact, for like many endpoints has like a 60% failure rate. But the Spotify API, when you want to interface with it, you have like all sorts of constraints. So I think most importantly, you have API rate limits. And the way how you want to deal with API rate limits is not just like whatever in a while true loop, just spin through it until it works. So it's like when you've been limited, every subsequent try that you do makes everything like often exponentially worse. So when you've hit the rate limit, you really want to make sure that you wait as long as the Spotify API tells you. Otherwise, like the app will just like get into a bad spot. And this gets really hard when you have like multiple tabs open or multiple workers that all try to like use the Spotify API. So and given that I don't operate a API where I could just say like, oh, I have an API and that is like the only thing that interfaces with the Spotify API, I use the same idea, but instead of having a deployed server, I have a shared worker, which is like basically like a web worker, but a singleton. That is the only thing that is allowed to talk to the Spotify API. The different windows and different threads talk to that instead, has like this identical API interface as for the Spotify client. And now that thing is in an intelligent way trying to handle access to Spotify. So it keeps a queue for the different requests. It does caching, it does rate limiting, it does retries, mentioned the 6% error rate. It does retries, and that's a pattern like as I was now able to explain that like in 2 minutes or so, but to implement that in JavaScript like properly takes a long time, or at least for me took a long time. With Effect, you have like primitives for workers, you have primitives for like proxying, you have primitives for rate limiting, you have primitives for queues, you have primitives for all the things I need, and this is basically like me just putting Lego bricks together instead of having to build everything myself. So I think this was kind of like a nicely self-contained use case. Oh, and yeah, I have also metrics here for like the number of Spotify calls I'm making. Any questions about that? I mentioned the app level task scheduling. I think I've already mentioned all the important parts there. What's one interesting thing about it as well is like you get really nice visibility into the stuff your app is doing. So if you use temporal at some point, you might know like that you can see the different workflow runs, etc. Or if you're like on your computer, you might see like the activity monitor to know what's currently going on. And so I have very nice visibility into this, also combined with OpenTelemetry. And building something like this, I could build like the task manager on top in a day, whereas like without Effect, it would have just like taken me forever. Another thing that's related is you might have seen this thing before in my demo. I call those like app vitals. I think it's a very common thing that you have when you do game development. Do you see like how many textures are currently loaded, what are the FPS, and so on. This is for me super useful in the when I'm building the app, because I can directly see what's going on in the app in the same way as like a doctor in a hospital sees what's going on with a patient. They don't need to run all sorts of tests. They have it like all there, or like a pilot in a cockpit. I have basically the same thing for my app, and I can put there whatever is useful for me, like real time. So this is just a very like pretty easy to build, and it gives me like very high value. And I also have like some vitals here for effect. And the general gist of this is I like building dev tools, and I also build like dev tools just for this use case, just for this app. And I want to encourage like everyone to do that. This is, don't wait for other people to build dev tools for you like a few years. Just like build them yourselves. You know your domain. Automate your workflows, and it's going to be a lot more fun and pay big dividends. This is kind of like the idea of like how the task scheduler is implemented at the end of the day. It's just, sorry, just too small, but I'm gonna post my slides. Here it basically just says request idle callback. It's a browser API which allows you to, calls you back if the browser currently has a little bit of wiggle room still in the frame left. And then as you do the work, you can ask the browser, hey, am I still good, or should I yield back? And so it's pretty simple. And given that I can just provide that to Effect does like all the rest for me. And I think this is it. Yeah, this was it.